Hi, and welcome to Allen High School's discussion of chemistry at the PreAP 10th grade honors chemistry level. We're in the midst of our discussion of thermochemistry, and then we'll move into, at the end, a little tad piece of nuclear chemistry. Now, what we're going to be doing next is describing heat changes, talking about the different ways that we as scientists communicate changes in heat energy in a system. So the first thing that we want to do, whoops, I didn't mean to move that box on you. There we go. First thing that we want to do is get some of our definitions into place. And you know some of these definitions already. I'm going to run through this quickly because these are terms with which you are already familiar. The enthalpy is given the symbol delta H. That's the change in heat for systems that are at constant pressure. That's really key. Most of what we're going to do in this unit will be constant pressure. Most, but not all. Now, there are two types of processes with enthalpy. There is exothermic. That's a negative delta H. And in this case, heat is lost or released by the process. Now, since heat is released by the process, your surroundings, which would be your hand if you were holding onto that Erlenmeyer flask, would get hot. Temperature would go up. Endothermic, it's like a cold pack. You know, you kind of pop this little disc. I've got one in my room. I need to heat up and we'll give it a shot. Endothermic is positive delta H, and it's when heat is gained by a process, whether that process be dissolving, reacting, whatever it is that we're doing, some sort of reaction. Salts are often endothermic or exothermic dissolution. Most would be exothermic, but there's a few where it's endothermic. Okay, and in this case now, our system, the chemical reaction going on side, needs heat. So heat is going to be pulled in from the surroundings, and therefore the temperature will decrease. And that's critical. You should be able to know that when the surroundings get hot, it's exothermic. If the surroundings get cold, it's endothermic. Now, I came up with this little chart to summarize, to help us wrap our minds around all the different ways that this is communicated, because it's not simply communicated, absorbed, released. Okay, so here's a chart in which we talk about verbally, we would say energy, if it's endothermic, is absorbed. So you want to look for words like that in a problem. If it's exothermic, we say energy is released. Now, we just said in endothermic, the temperature of the surroundings decreases or gets colder. So we'd be a decrease in temperature. And here we would see an increase in temperature. It would get hotter for exothermic. Enthalpy is positive for endo, negative for exo. So you see, problems can choose one or more of these ways to tell you that it's endothermic or exothermic. In a chemical reaction, if it's endothermic, since heat is required to be provided, a continual supply of heat energy or some sort of energy required for a chemical reaction, since it's required, it's a reactant. In exothermic, since it's released, that means it's formed. And things that are formed in a chemical reaction are written on the product side. Now, this last one is a potential energy diagram. And if you look on the y-axis, we have potential energy in kilojoules. Remember, that's energy, that's attractive forces involved in bonding and intermolecular forces and so forth. This is a very vague x-axis, the reaction pathway, going from point A to point B. So here are our reactants. So here's the potential energy of our reactants. Here's the potential energy of our products. And Our enthalpy, delta H, is going to be the potential energy of our products minus the potential energy of our reactants. So since we have a big number minus a small number, we're going to get a positive number. Okay, it's always final minus initial. Now here, since we have a small number and we're taking away a big number, energy is going down, delta H would be negative. So that's how we would do those potential energy diagrams. Now, all I'm talking about in these for right now is the discussion of endothermic versus exothermic. In our next video, I want to go into these in a little bit more detail and talk about some of the other nuances of a potential energy diagram in order to prepare us for our next unit. So until then, this is signing off.